Welcome back to the learning module on space. And what we're going to do in today's activity is basically expand on the lecture that dealt with longitude and latitude and talked about kind of the graticule and how we can determine basically the location on a globe using longitude and latitude, or calculate the latitude and longitude of a given location. So one of the things that I really want you to think about today is that the globe is not really the most practical thing for navigation. If we were trying to find latitude and longitude on this, we're kind of limited by the spacing of the meridians and the parallels, and we can't really use it for navigation. We're not going to carry this around. It's not going to be in our car, so not practical. More common is that we may use some sort of flat paper map, or maybe we use a virtual globe, which is what Google Earth is. So I want you, after watching this activity, to be able to use the virtual globe to also describe the visual appearance of the graticule. I also want you to be able to locate on the virtual globe places that are identified using longitude and latitude. And then I want you to be able to use longitude and latitude to also navigate to a place. And then along with those same lines, if we're using longitude and latitude and we can extract that information from Google Earth, we should also be able to determine the latitude and longitude between places. Okay, so to get started, you need to first open up Google Earth. I already have the program opened up here. And when the default viewer pops open, it should look something like this. And what you'll notice is that we cannot see latitude, we cannot see longitude, so we see no parallels, no meridians, no equator, neither of the tropics, we see nothing. And that's really because the more information that's on a map or a virtual globe that isn't necessary just clutters it. So if we want to turn on both lines of longitude and lines of latitude, we can hit the control button and then hit L. So Control L. And we can see the graticule is now overlaid on the virtual globe. And this is really nice because it's obviously better than my hand-drawn example. And it allows us to kind of explore digitally what lines of latitude and longitude look like. And so just as before, we know that the equator right here splits the Earth into the northern and southern hemisphere, right? So we can see north 30 and the Tropic of Cancer, which is north 23.5, Tropic of Capricorn, which is south 23.5, also known to be negative 23.5 degrees. And then we can also zoom over here and we can see we have the prime meridian, which is a line of longitude, and this is a start. So we have 0 degrees longitude, and then as we move westward, we count up to 180, and as we move eastward, we count to 180, and these all end up over at the anti-meridian. And again, I want you to remember that the anti-meridian creates a great circle that splits the globe. The anti-meridian and the prime meridian create a great circle that splits the globe into the eastern and western hemispheres. Now, one of the things that's really visible on this is a topic we discussed a little bit earlier, which was converging meridians. And so we know that 1 degree of latitude is approximately 69 miles. We also know that 1 degree of longitude is approximately 69 miles, but as we move poleward, it approaches 0, and this is because of converging meridians. And so we can see here that as we move poleward, the meridians all converge at both the North Pole and the South Pole. And so if we zoom in really close, this is why 1 degree of longitude is much less at the poles than it is at the equator. And we can see that as we move outward from the poles, these grids get bigger and bigger, which ultimately means that angular measurements are also affected as a result of converging meridians, or area measurements are also affected. Okay, so what I want to do here is explore a little bit how we can use Google Earth first to identify the coordinates of a place on the surface of the Earth. And we've briefly covered this, but I want to go into a little bit more detail now that we're very familiar with the concepts of longitude and latitude. All right, so the first thing that I'm going to do is, there's a situation going on in Syria right now, and so why don't we go ahead and zoom in to Damascus, Syria. So I'll just type that into my search menu, and Google Earth will automatically navigate to that location. Now I want you to pay attention that as we zoom in, new grids kind of pop up. So it's the more we zoom in or the more we zoom out, we get less detail, and the grid spacing gets bigger and bigger. As we zoom in, they give us more and more detail. Sometimes it's overkill, but it's a nice function. Okay, so if we really wanted to, we could keep on zooming in, and we could use these reference grids to basically find out where Damascus is located. And we can see here that maybe the closest intersection tells us that we are in the Eastern Hemisphere at 36 degrees, 17 minutes, and 24 seconds. We can also tell that we're in the Northern Hemisphere, so this would be a line of latitude at 33 degrees, 30 seconds, and 36 minutes. So that's nice, but it's not perfectly precise. And so what I want you to reference is over here in the bottom right-hand corner. This gives us all sorts of information about longitude, latitude, elevation, and also the zoom level that I'm at. In addition to that, it provides us with some time information or temporal information, so we can tell that this image is from 2017. So these coordinate pairs, the X and the Y coordinate, are referenced to wherever my mouse cursor is. So if I go over to this pin, which is where Damascus is, I can see down in the bottom right-hand corner that this is actually 33 degrees, 30 minutes, and 50 seconds. So it's a little bit more of a precise measure. Along the same lines, the longitude coordinate is 36 degrees, 16 minutes, and 18 seconds. So if we reference that bottom right-hand corner, it's going to give us a much more accurate and precise measure of the X and Y location as opposed to using this reference grid. So that's one of the real advantages to using a virtual globe. Okay, so now I'm going to zoom out. So that was basically a demonstration that illustrates how to find a place on the surface of the Earth and then extract the longitude and latitude position. All right, so now let's imagine that we don't know the place name or the location's name, but we do have some coordinates. We can actually search in the search area using those coordinates just like we can search using place names. So for the sake of time, I stashed some stuff in my clipboard. So I'm going to go in and I'm going to paste the latitude, and then I'm going to hit comma, and then I'm going to paste in the longitude. And then we're going to search. All right, and so this is actually referred to as being the airplane graveyard. It's a place where the military stores all sorts of old planes, some of which don't work, others for parts, and some are actually fully operational in case there's some sort of event where they need that. So using basically latitude and longitude in degrees, minutes, and seconds, we can zoom in anywhere on this virtual globe, and we can basically find out the place name of that particular place, and we can reference where it actually lies in relationship to other things. So really nice kind of feature that we can use when we're exploring space of geographic objects. All right, so one thing I want you to notice is that in this particular example, we used degrees, minutes, and seconds, and we can also search for places using decimal degrees, which you know is a little bit different. And remember, when we use decimal degrees, we use negative and positive signs to basically represent which hemisphere that we're in. So again, we could search for we could go negative 37.33. and then we could hit comma. And then we're going to try to get close to Radford University, so that would be in the Western Hemisphere, and we'll put in 81, negative 81, and we would actually use a positive for the latitude because we're in the Northern Hemisphere. And we'll do negative 81.55, and we'll go ahead and search. All right, that's great. And so that dropped us in somewhere in Southwest Virginia, all right, just north of Tazewell County. So again, this is an example of how we can find places on the surface of the Earth using longitude and latitude measured in decimal degrees. So we can use both degrees, minutes, seconds, and decimal degrees. And then, just like in the previous lecture, we could put pins anywhere on Google Earth and we could identify the XY coordinate pairs, and then we could mathematically calculate how many degrees of longitude and latitude we have covered. Imagine if we were traveling from one place to another, or maybe we just wanted to do map measurements. Okay, now, another thing that I want to mention is that down here we have reference to our XY locations, and by default this is done in degrees, minutes, and seconds, but we actually have control over what types of units we want to use to represent our X and our Y locations. And so if we go up here to tools and we go down to options, we can see we want to show latitude and longitude, and we may want to change to decimal degrees. So I can hit decimal degrees, and then I can hit apply, and we can see that we've changed to this different type of representation, where we have positive and negative signs that represent the hemisphere, and instead of minutes and seconds, we use decimals after the degree to represent that proportion. Now, I would like to also mention very briefly that when we're dealing with decimal degrees, there are basically 60 minutes that are in 1 degree. There are also 60 seconds that are in 1 minute, and that means that there are 3,600 seconds in 1 degree. And these numbers are going to become important in later modules where we learn how to convert between degrees, minutes, seconds, and also decimal degrees. You'll also notice in this dialog box that there are options to turn on something called Universal Transverse Mercator. So this is a different type of gridded system that we use to represent geographic objects on the surface of the Earth. And if we hit apply, we can see that this uses meters instead of degrees. So this is moving to a linear form of representing geographic objects instead of an angular form. And we're going to get into a little bit more detail in the lecture right after this, where we talk about projections. And projections are basically the mathematical process of converting from a three-dimensional Earth or a round globe or a sphere into a flat paper map or a Cartesian coordinate plane. Now, in addition to the Universal Transverse Mercator grid, we could also turn on the Military Grid Reference System. And all of these things are important to know that they are there, because we may be dealing with data sets that reference different types of grids, or maybe they don't rely on the graticule or longitude and latitude to represent geographic objects. So we need to be comfortable with many different forms of what we refer to as being coordinate systems, which are the grids that we use to represent geographic objects on the surface of the Earth. Okay, that's it for this short activity on examining longitude and latitude using a virtual globe. So I want you to go ahead now and check your understanding.